Good morning, everyone. It's my great pleasure to be here and share with you the latest in our journey in construction robotics. Personally, my research has started with the development of autonomous quadrupedal robots like Animal. I did this at ETH, one of the top 10 universities in the world. We deployed these highly mobile and dynamic machines in some of the most challenging real-world environments, and among other, even won the prestigious DARPA Subterranean Challenge here in the US about 2 years ago. In our research, we discovered that quadrupedal robots and construction equipment actually have a lot in common. As you can see, they share a very similar morphology, and thus we can leverage the same technologies for control, for environment perception, and even for full-scale autonomy. And this has inspired us to start automating excavators and then finally to spin out this technology as Gravis Robotics. For controlling these robotic excavators, we have pioneered a data-driven approach. So what we're doing is we're using reinforcement learning, which is much better suited to the complexity and the unpredictability of excavation tasks, as opposed to classical, more rule-based approaches. In fact, we're running hundreds of thousands of simulations in the virtual space to train a control policy, and we take this neural network-based controller and deploy it on the real machine. Like this, we can dramatically accelerate this learning process without the costs and the carbon footprint that we could have with a physical trial. At Gravis, with our proprietary technology at hand, we have already managed to automate fairly complex tasks, like precise earthwork with heterogeneous terrain, or even building dry stone walls from irregular rocks. As you can see, the excavator becomes much more than a construction machine, also taking the roles of the planner and of the surveyor. Precisely scans the size and the shape of each stone, and then automatically generates and executes an optimal stacking plan in order to create the static shape by ensuring structural stability and efficiency. This wall and this freeform earthwork were done autonomously, using almost 1,000 stones, and all of that at centimeter precision. And moreover, this construction reduced the overall CO2 emissions by more than 40%. And this is just the beginning. I hope this gives you a glimpse into the future of what will be possible with robotic construction equipment. Now, scaling up this sort of technology and this sort of innovation from research and prototypes to products comes along with a totally different number of challenges, especially with the complexity of hydraulic construction equipment. So we're super excited to see companies like Hyundai that are striving towards autonomous construction, with their Concept X in 2019, and then again with the Concept X2 in 2023. Because our world really needs such world-class equipment providers that are seriously committed to the idea of construction robotics in order to overcome labor shortage, and in general to make construction safer, more affordable, and more sustainable. At Gravis, we really share this vision with Hyundai. And we are excited to start the collaboration and bring the Gravis technology onto Hyundai machines. We believe that together we are able to unlock unprecedented capabilities for future construction and to transform the very nature of this industry. Thank you very much.